I am Anil Kumar. Welcome to my series on exponential and logarithmic functions. Here we have 5 very interesting questions. I rate them at level 3, slightly difficult questions. These are the examples which relate exponential and logarithmic functions, and strategies adopted to solve them will help you to understand all the concepts in this unit. So the first two examples, we have two simultaneous equations, the exponential equations, which will be solved using logarithms. Then question number 3 is, when we have series of logarithms, how do we work with them? And question number 4, we have log to the base e, the natural log ln x involved. And question number 5 is an inequality with exponential equation. Now let us see one by one how to solve these questions. You can always pause the video, answer these questions, and then look into my suggestions. Now let us see how to solve this question. Solve x plus y times y to the power of y minus x equals to 1 and x plus y to the power of x minus y equals to 5. So let's begin with let's call them as our equation number 1 and 2. So we'll begin with equation 1, which is x plus y times 5 to the power of y minus x equals to 1. Taking log on this side, we'll take log to the base 5, since we see that the number 5 is being used in both the equations, right? So we get log to the base 5 of x plus y times 5 to the power of y minus x equals to log to the base 5 of 1. Now log to the base 5 of 1 is 0. Here we can use the product, means you could write it as a sum. So we get log to the base 5 of x plus y plus log to the base 5 of 5 to the power of y minus x equals to 0. Now log to the base 5 of 5 to the power of y minus x is y minus x. So we could write this as log to the base 5 of x plus y. Let me add one more step. Let me write this as y minus x times log to the base 5 of 5 equals to 0. Right. Now that is 1. So we get log to the base 5 of x plus y plus we can write this as minus of x minus y. So we'll take y minus common, rather write it as x minus y equals to 0, since log to the base 5 of 5 is 1. So that gives you one equation as x minus y equals to log to the base 5 of x plus y, correct? Let's call this as our equation number 3. Now let us also solve the second equation, taking log on both the sides. Let me do it in a different thing. So we get here x plus y to the power of x minus y equals to 5. Taking log, we get log to the base 5 of x plus y to the power of x minus y equals to log to the base 5 of 5, right? Now that is 1, and this is x minus y times log of the base 5 of x plus y equals to 1. So from here we can say that the x minus y is 1 over this, right? So we can write here x minus y equals to 1 over log of to the base 5 x plus y, correct? So that becomes our equation number 4. So from equation 3 and 4, we see that x minus y is log to the base 5 of x plus y. Here we see x minus y times log of 5x plus y is 1. Well, we can replace this with that and then get equation number 5, okay? So using 3 and 4, we could write, here we have x minus y as log 5. So we get basically log to the base 5 of x plus y times log to the base 5 of x plus y equals to 1. So that is the square of this. So that is to say log to the base 5 of x plus y whole square is equal to 1, or we get log to the base 5 of x plus y is equal to square root of 1. So we'll write plus and minus, which is plus or minus 1. So we get two values for x plus y. So we can get x plus y equals to 5 to the power of plus and minus 1. So we have two values here. Either we get 5 or we get 1 over 5. Correct? So let's call this as our equation number 5 and 6. So we get two values for x plus y. And we know that x minus y for us is equal to, we could use one of these expressions, equation 3, right? So we'll use equation 3 and equation 5 and 6 to find the value of x plus y, correct? Okay, so let's take one of them first. So we'll take x plus y equals to 5, and here we know x minus y equals to log to the base 5 of x plus y, right? So that gives us x minus y as log of 5, which is 1, right? So what we get here is x minus y equals to 1. So that gives you, let's say, equation number 7, right? Now, using these two equations, when you add these two equations, which is equation 5 and 7, so when you add equation 5 and 7, so as you can see, we get x plus y equals to 5 and x minus y equals to 1. So if I add them, I get 2x equals to 6, and that gives you x is equals to 6 by 2, which is 3. Right, so if x is 3, then what is y equals to? Y is 5 minus x. So y is 5 minus x, which is 5 minus 3 equals to 2. So one set of values which you get here is 3 and 2, right? So 3 and 2 becomes one of the solutions. So I should say solution 1. Now we can actually use the other value, which is 1 over 5. So in that case, we have x plus y equals to 1 over 5. And in that case, x minus y will be equals to log to the base 5 of 1 over 5. So which is log to the base 5 of 1 over 5, which is minus 1. So now we get x minus y as minus 1. And here we have x plus y as 1 over y. So if I add them again, so I get what? I get 2x equals to 1 over 5 minus 1, which is 5 minus 4 over 5, correct? So that gives you the value of x as equal to half of this, or minus 2 over 5, correct? So the value of x is 2 over 5. And now you can find the value of y as equal to 1 over 5 minus 2 over 5, or add this up, right? So we get the equation of, let me do it here. So what we just calculated is x is equals to minus 2 over 5. And we know, so we are actually working for the second solution. Let's make this like this. And we know that x minus y is minus 1. So we know x minus y is minus 1. So that means y is x plus 1, correct? Okay. So we get minus 2 over 5 plus 1. So that gives you minus 2 plus 5 over 5, which is 3 over 5. So the second solution which we get is minus 2 over 5 and 3 over 5. Is that clear to you? So that is how we are getting the solution for this particular equation. So we have two solutions here. So we have solution 1, which is the coordinate point 3, 2. And the other one is minus 2 over 5, 3 over 5. Is that clear to you, right? So that's a very beautiful question. So I hope you understand the solution. So basically what we did was, using log to the base 5, we found two equations with x plus y and x minus y, and then we solved those equations out to get the values. So that is how you could solve this. Here we have system of equations to solve. X to the power of y equals to 2. 2x to the power of y squared equals to 64. So these two exponential equations are given to us. We need to find what is the product of x and y with four options. You can always pause the video, answer the question, and then look into my suggestions. So we are given here x to the power of y equals to 2. Since we have y squared, let us square this, right? So we get x to the power of y squared will be equal to 2 squared, right? Which is 4, right? Okay. So that is what we get from our equation number 1. We get this equation. Let me call this as our equation number 2. Now if I look into rather 3, right? Let's call this as equation number 2. So from equation 2, we are given 2x to the power of y squared equals to 64. So if I open the bracket, I get 2 to the power of y squared times x to the power of y squared equals to 64. Now, x to the power of y squared is 4, so I'll replace this with 4. So we get 2 to the power of y squared times 4 equals to 64. So we could write this as 2 to the power of y squared equals to 64 over 4, which is 16, right? Now, that gives us the value of y, correct? So taking it to the right side, we can write, let me rewrite the equation. 2 to the power of y squared is equal to 16, which is 2 to the power of 4. So that means y squared is equal to 4, or y equals to square root of 4, which is equal to 2. Now since these are exponential equations, we will take x as greater than equal to 0, right? So the base should be actually greater than 0 and not equal to 1, correct? That is the restriction. Okay. So anyways, we'll take the positive value of 2 here. Now, we know x to the power of y is 2, right? So that is given to us. So we are given, so we get the y value. So let's call this as equation 4. Now, since y is 2, we have x to the power of y equals to 2. So that means y is 2. So x squared equals to 2. Now, so x is equal to square root of 2. So we get the value of x as square root of 2. Let's call this as equation 5. We need to find the product of x and y. So x times y is square root 2 times 2. So we get 2 square root 2 as our answer, right? Which is option B for us. So that is how we can solve this system of equations on logarithms. So I hope that helps. We need to solve this equation, which is log to the base 2 of log to the base 3 of log to the base 4 of 3 to the power of 5x minus 6 minus 17 equals to 0. You can always pause the video, answer the question, and then look into my solutions, right? Now we are saying log to the base 2 of all this is 0. It means what? It means that all this should be equal to 1, right? Since we know that log of anything, right, any base b of x equals to 0 means x equals to 1, right? So that basically means that log to the base 3 of log to the base 4 of 3 to the power of 5x minus 6 minus 17 should be, one more bracket, should be equal to 1, correct? So only when all this is equal to 1, then log to the base 2 of 1 will be 0. Perfect. Now, we can convert this to an exponential equation. So 3 to the power of 1 should be all this. So we get now log to the base 4 of 3 to the power of 5x minus 6 minus 17 equals to 3 to the power of 1, which is 3. right? Again, we'll use the exponential form, writing this as 4 to the power of 3. So we get 3 to the power of 5x minus 6 minus 17 equals to 4 to the power of 3, which is 64, right? 4 times 4 times 4. We can take 17 to the right side, so we get 3 to the power of 5x minus 6 equals to 64 plus 17, which is 7 plus 4, 11, we get 81. So we get 3 to the power of 5x minus 6 equals to 81 is 3 to the power of 4. With the same base, we can equate the exponents. So we get 5x minus 6 equals to 4. 5x equals to 4 plus 6, right? So we get x equals to 10 over 5, which is equals to 2. So we get our solution as x equals to 2. So our answer in this case is x equals to 2. Is that clear? So that is how we can actually solve this question. It's kind of important to understand how we use this, right? You could also say like this. You can convert this to exponential form. So you can write this as 2 to the power of 0, right? So you could also write this as 2 to the power of 0 as 1. And therefore, all this is equal to 1, right? And then follow the same method to simplify and then finally get your answer, which is x equals to 2. Here is an open question on logarithms. Solve ln x minus log x equals to 1. So ln x is to the base e and this is to the base 10, correct? You can always pause the video, answer the question, and then look into my suggestions. So we are given that ln x minus log x is equal to 1. So let's change the base to, let us say, ln, right? So we get ln x minus, changing the base to ln, we get ln x over ln 10 equals to 1. Now multiplying by ln 10, we get ln x times ln 10 minus ln x equals to ln 10, right? We can take ln x common. So we get ln 10 minus 1. This is a constant, right? Ln 10 is a constant. So from here, we can write that ln x is equals to ln 10 divided by ln 10 minus 1. So that is how you could isolate it. And from here, ln is to the base e. So we get x equals to e to the power of all this, right? E to the power of ln 10 over ln 10 minus 1, correct? So that is how you could actually solve this question. Now let's also find approximate answer for this. We get x as equals to e to the power of ln 10 over ln 10 minus 1, right? So approximately, solution, the answer could be e to the power of, so we have exponent as within brackets ln 10 minus, so we divide this by, within bracket we can write all this, ln 10 minus 1. So we have ln 10 minus 1 bracket close, which is equal to approximately 5.85739, right? That is the value. So the value is approximately 5.85739. So that is the answer. But I hope you understand how, with the help of change of base, we can actually solve this question. Solve the inequality 2 times 3 to the power of x less than equal to 4 to the power of x. So what we could do here is, well, 2 is a power, we could first divide by 2. So let's begin by taking, let's copy the question first. Okay. So we have 2 times 3 to the power of x is less than equal to 4 to the power of x. So let's divide by 2. So we get 3 to the power of x is less than equals to half of 4 to the power of x, correct? Now 4 could be written as a power of 2. So we could write this as 2 to the power of 2x, correct? So 2x. Now that means 3 to the power of x should be less than 2 to the power of 2x minus 1, right? So that's what we get. Now, all these functions, now what can we do? They are positive. It is kind of important to understand. So both of them are positive functions. Always their value is greater than 0. Now we can take log on both the sides. So let's take log to the base, we can say ln, log to the base e also, or log to the base 10, right? So okay, let's take log on both sides. So we get log to 3 to the power of x less than equals to log of 2 to the power of 2x minus 1. Now that means x times log 3 is less than equals to 2x minus 1 times log 2, right? So we can bring the x terms together and solve it further. So in that case, we get, let's bring on the right side, we have got 2x log 2 here. Okay. So we could bring it on left or right, and it doesn't really matter much. So let's open this first. So we have x log 3 less than equals to 2x log 2 minus log 2. So we get this constant here, log 2. Let's take it to the left side. So we get log of 2 and these things, which is 2x log of 2 minus x log of 3. So we have log of 2 should be less than equal to x is common. Now here we could write this as log 2. Let me do it in 2 steps. So we get 2 here, right? Minus log of 3. Okay. So we have log 2 is less than equal to x times log of 2 square minus log of 3. So we can get the value of x as log of 2 divided by 2 square is 4. So we could write this as log of 4 minus log of 3. Is it clear? And the value of x should be greater than equal to this value. Okay. So that becomes the solution. Now if the calculator is allowed, then you can always check the value. So we have here log of 2 divided by, within brackets, log of 4 minus log of 3, which is equal to 2.4, approximately 1, right? So that becomes the answer for the given question. Correct? So we get a solution as x should be greater than equal to 2.41 in this particular case, right? To 3 significant numbers, right? So that could be a good answer. X greater than equal to 2.41 if we are taking 3 significant figures. So I hope that helps. So with that, we have discussed with you some interesting questions on exponentials and logarithms. I hope you understand and appreciate them. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.